Now that summer is winding down and you've already spent lots of time in the water, I want to show you now how to figure out how much pee is in any pool.
Yes, we have strong evidence that people do pee in the pool. So we're going to try to find a way that we can measure that pee without actually measuring pee. I'm going to apply my new strategy based on the amount of artificial sweetener that's in the pool. We know artificial sweeteners don't come from anywhere except for urine. So that's the only logical source for them. If we find them in the pool and we know how much artificial sweetener is in the average person's pee,
Right.
and then using that, we can estimate how much pee is in the pool.
Got it. You can actually take a sample of pool water and directly measure the amount of urea in there. But the problem with that is humans also excrete urea through things like sweat, which is also very common in a pool. So you can't tell how much of that urea actually came from pee. To get around that, she looked at the amount of a certain artificial sweetener in the sample called asulfame potassium, which is really common in food products such as these. Oh, and also all of these. So pretty much everything. The reason drinks like these are 0 calories is because you taste the asulfame potassium sweetener, but the chemical compounds aren't broken down at all by your body. So more than 99% is passed through in your pee within 24 hours. And therefore the only reason this would be in the pool is if it passed through a person first. And just to be sure, we measured the source water at both locations because sometimes trace amounts of the sweetener can be found in the water supply. And if so, we just subtract that from the results. The mass spectrometer takes about an hour to get results, so while we were waiting, Lindsay told me something that really surprised me. Chlorine in pools is obviously really helpful because it breaks down harmful bacteria, viruses, and microbes. However, there is one big downside, and that is it reacts with urine to create a byproduct called trichloramine.
So trichloramine is what's responsible for that chlorine smell that you might get when you enter into an indoor swimming facility.
So I devised an experiment of my own to see if this was really true. For the experiment, I got 2 5-gallon buckets and filled them with pure water. Then I added 4 times the recommended concentration of chlorine for that volume of water to both buckets. And then only in the bucket labeled B, I added just a little bit of pee. And then I let it sit for a couple days.
All right, so it's been 3 days, so this is the moment of truth. So the first thing I notice is visually they look the same. You can't tell one bucket from the other as far as color of water goes. So I'm gonna start and smell this one first. So that doesn't smell like anything. That smells just like water, even though this has 4 times the recommended concentration of chlorine for this volume, which makes me nervous to smell this one. What? That is crazy. This smells like a pool, even though the only difference between these two is this has a little bit of pee in it. This is a nostalgic smell. This smells like summers and vacationing at hotels with pools and water parks. Turns out it was just pee. But the problem is, it's kind of bad news for both your lungs and your eyes. When your eyes are really red after swimming for a while, that's actually because of the trichloramine from the pee, not the chlorine. Which now makes sense because Michael Phelps admitted to always peeing in the pool, and he says all his buddies do too. So be cool and don't pee in the pool. Now let's go see Lindsay's results. In Lindsay's research, she sampled 20 public swimming pools and 10 public hot tubs. The average concentration of sweetener for the pools was 470 nanograms per liter, and for the hot tubs was 2,247. So after running all of my samples, we found that here in my friend's backyard pool, they had a concentration of artificial sweetener of 69 nanograms per liter, which equates to just under a gallon of pee, which is actually much lower than the average, but that makes sense because this would see much less use than a public pool. Their spa had a higher concentration than the pool at 103, but since a spa contains much less volume, that equates to about this much pee. So far, not bad. which leads me to believe that the water has been completely replaced recently, which happens from time to time for various reasons. If this pool had the average concentrations reported by Lindsay, for these volumes, we would expect to see over a gallon of pee in the hot tub and about 13 gallons in the pool. And Olympic pools will contain, brace yourself, over 130 gallons. There are some caveats to these generalizations, so check out the links in the video description for published papers from both scientist Lindsay and Professor Blatchley. So in conclusion, what does this all mean? For starters, let me just say pee is generally considered to be sterile, meaning it's free from bacteria and any living things. You could totally drink the stuff and not get sick. In fact, in some cultures, that's totally a thing.
You drink the grandson's pee and it's gonna help you.
Additionally, urine is made of 95% water and just 5% of dissolved solids like the urea stuff we've been talking about. The fact that pee is so dilute at 95% pure water is in part, disappointingly, why it's really hard to make a chemical you could add to any pool that will magically turn blue if someone pees in it. Having said that, I suppose it's still a little gross knowing you're swimming in even just a small amount of pee. I guess at the end of the day, my advice would be to be cool and don't be in the pool. And then at that point,
just keep swimming, just keep swimming, just keep swimming, swimming, swimming.
just maybe take a shower when you're done.
Just keep swimming, just keep swimming, just keep swimming.